Welcome to this lighting effects and reflections course. In this chapter on fog and volumetric light, we're going to take a look at the different ways you can set up fog and related effects in the Unreal Engine. We're going to start off with atmospheric distance fog, then we're going to do exponential distance fog, light shaft bloom and light shaft occlusion, and we're going to end with proper volumetric fog and lighting. In the level fog_volumetric lighting, which you can find in start asset, which is part of effects and reflections, and that's part of lighting and rendering, you have this level over here. We're going to start with the atmospheric fog, which you can find in the placement panel here, visual effects, and then you have atmospheric fog. You can just drag it in, it doesn't matter where you place it, it affects the entire level at all times. It's going to be a little bit easy to see what's going on if we hide the sky. So I'm going to click on the sky and press the H key on the keyboard, H from hide, to hide the sky. So now we only see the atmospheric fog. The atmospheric fog is a more complex one of the two. Exponential height fog, which we'll do later on, is actually a simpler one. But we need to do that later on because exponential height fog is going to give us our eventual support for proper volumetric fog, which we want to talk about later on. Either way, atmospheric fog, being the more complex one that it is, it doesn't just create a layer of fog in the environment, it actually creates the horizon as well. You can see the colors are rather subtle, but it creates a difference in color. In fact, there is a property in the light itself, in the sunlight, the directional light. So if you click on the directional light and you look in the properties here and you expand the advanced options. So it's going to look like this for you. Press the arrow, that arrow, to expand the advanced options of the light section. And then there's a property called atmosphere fog sunlight. If you enable that, then the atmospheric fog automatically detects this sunlight, this directional light, and adjusts the color based on the angle and the position of that directional light, and it adds a sun disk. In fact, the sun disk could be disabled here, as you can see over there, and if you were to rotate this light, the position of the sun would automatically match. If you move it up and down, you can see it actually starts to blend in even in colors if the sun is positioned low enough. Let me undo that a few times. Now, the settings you have available in the atmospheric fog allow you to change things like the density, the brightness, and some other settings, so feel free to experiment a little bit with the settings and see where you end up. As mentioned, this is the more complex of the two and the more advanced ones. It's not always desirable to have it actually create the entire atmosphere, the atmosphere around it. Sometimes you simply want a more straightforward distance fog. That's where the second one comes in. I'm deleting the atmospheric fog I just placed, and in this next section we're going to instead place exponential height fog. I'm going to drag it in. Again, it doesn't matter where you place it, it affects the entire environment. You can see this too will automatically detect that this directional light has the property for sunlight enabled. So you can see there is subtle, but there is a difference in color here, which is the difference in color from the sun. Again, if you rotate it, you see this difference in color changing, but it's more simple. In the settings of the exponential height fog, you can see the fog density, and you can try to increase that. You can see it speaks for itself. You simply get more distance fog in here. You can change the color. In fact, you have the fog in scattering color and the directional in scattering color. So those are two colors you have available. That is the blue tint you see there. That is the fog in scattering color, and the yellowish tint here surrounding the position the sun would have, that is the directional in scattering color. Some additional properties you can play around with and experiment a little bit with, and I'd also like to point out that it's not just distance fog, it's also height fog. You can see a property here is called height fog fall off, and the max opacity and some other settings. If you change that, and this is going to be possibly hard to preview, see if we can somehow do that. You can see if you move it down, the fog actually decreases. This is very hard to do in this level that we have over here. But if you would have a level with, for example, a tall tower, the tall tower would be outside of the fog. The fog reduces in opacity the higher you go, which is an interesting property. So what I'm doing now is I'm going to set up the fog density to say 0.25 or so it's relatively dense. And then we're going to move on to light shaft bloom and light shaft occlusion. Now, light shaft bloom and light shaft occlusion in themselves have not really anything to do with fog, but the effect that they create very much so matches what you would expect of light traveling through fog to look like. So again, this is not dependent on any of these specific fog actors or settings. You can apply this at any time, but it does match very well. If you click on the directional light and you look in the settings over here, then you can see there's a section called light shafts. And you have light shaft occlusion and light shaft bloom. If you enable light shaft occlusion, and then let's go to one of the trees, you can see what happens. You get these kind of God rays. And again, this matches very well with what you would expect to get in a foggy environment. You can again change the settings a little bit if you want to exaggerate it. Light shaft bloom works the same, but it's the other way around. So light shaft occlusion makes it darker, you get dark rays. Light shaft bloom gives you bright rays. I'm going to turn off the occlusion for a second and instead turn on light shaft bloom. Now this is a little bit hard to see, you can see it over here. I'm not sure how well it shows up on the video. So what I will do now is, that doesn't work either. See, we can try to change the color to make this obvious, just to exaggerate it. Set it to a very unrealistic color, but you can clearly see the rays coming through, which works very well. Also inside you can see the window here, you get very nice rays coming in. So that is light shaft bloom. And again, light shaft occlusion could be enabled at the same time, then you get both darker and brighter rays coming from the sun. Now lastly, you also have proper volumetric fog. In order to enable the volumetric fog, you need to have an exponential height fog actor somewhere in the environment. And then in the properties of that, there is a section called volumetric fog. This is where you enable it. So let's say yes, and then we're going to have to bump up the intensity a bit. If you set the fog density in exponential height fog component to, for example, 4, to really bump it up, you see what's happening. Again, if you look at the window here, you can see how the light actually illuminates the fog inside the room where it enters. You can look at the trees as well here. And again, you get a similar kind of God ray style effect here. It's a bit more subtle, but that's being applied there too. In fact, the best thing you can probably do is both have this enabled, volumetric fog, and then enable the light shaft bloom and light shaft occlusion on the directional light as well, which is currently disabled. So you have all of them combined. That would probably give you the best possible result. In fact, let's just do that for a second. Here is the directional light I have selected. I keep having it selected, but I go back to the tree here. I'm going to enable light shaft bloom and light shaft occlusion, and I'm resetting the bloom color. And now we have this. This is rather extreme, so it's a little bit much, but it shows a general idea how much you can do with this. The volumetric fog is actually using the volumetric light maps in order to lit itself. So the fog itself is actually light mapped, essentially. We don't have a very good example of that here in the environment, but if you would have a very bright, let's say the TV is emitting a very bright green light, the fog in this location would actually be receiving that green light and change color. You can see that a little bit with the spotlights we have over here. You can see with the spotlights, there is a cone of light coming from it. That's happening because there is a setting in every single light, and that setting controls the amount of impact it has on the volumetric fog. You can see here it says volumetric scattering intensity in the section on light. If you set that to 0, you can see it no longer impacts the fog. So this is the amount of impact it has on the fog. So it's great for making, for example, headlights of a car illuminate the fog on a autumn evening or something like that. So we've gone through fog and volumetric light in the Unreal Engine. That means we've taken a look at atmospheric distance fog, or the other type available, which is exponential distance fog. The fact that you can enable light shaft bloom and light shaft occlusion on a directional light, and that it really helps to build up the foggy atmosphere. And the fact that you can enable volumetric fog on an exponential distance fog, and how it impacts lighting and how every light can contribute either through volumetric light maps or through the setting on the light that controls the fog intensity.